When you look at a skyscraper, a massive bridge, or a giant dam, you see concrete and steel, right? You see these incredible feats of engineering. But the single most critical component in every one of them, well, it isn't a material at all. It's the people who build them. And that human element, it's both construction's greatest asset and, believe it or not, its single biggest liability.
So let me ask you this. Picture a construction site. You've got heavy machinery, you've got reinforced steel, super high-strength concrete, all this tough stuff. But what's the weakest material on that site, the one most likely to fail under pressure?
The answer isn't something you can hold in your hand. It's the human mind. Now, this has nothing to do with skill or intelligence. It's about the simple, universal fact that we're all human. We get tired, we get distracted, we miss little details, and on a construction site, those tiny momentary lapses, they can have absolutely catastrophic results.
All right, so in this explainer, we're going to break this whole thing down. We'll start with the human foundation of every single project. Then we'll look at what I'm calling cracks in concentration. Basically, why good, smart people make mistakes. From there, we'll trace the ripple effect of those errors. And finally, we'll look at how we can forge a much safer system to manage this ever-present risk.
So, first up, the human foundation. Because for all our amazing technology and automation, construction is still a deeply, fundamentally human job. A person draws the blueprint, a person welds the beam, and a person has to make that final call. People are the engine driving every single project from the ground up.
Now, when we talk about this risk, a term that always pops up is human error. But what does that really mean? This is so important. It's not about blame. It's really just a technical term for an accidental action that makes a system less safe or less effective. You gotta think of it like an engineering problem we need to solve, not a moral failing someone needs to be punished for.
Okay, so if it's not about bad workers, then why do these errors even happen? This is where we find those cracks in concentration. And the most critical thing to get here is that these mistakes aren't made by incompetent people. Nope. They're often made by skilled, experienced pros who are just put in a situation where an error becomes almost inevitable.
So what creates these situations? Well, it usually boils down to a few key culprits. Fatigue is a huge one. After a 12-hour shift, even the sharpest person's attention is going to fade. Misunderstood instructions are another. Just try hearing a complex order over the roar of a job site. And then there are just simple lapses in focus. A momentary distraction about a problem at home can be all it takes.
And the difference is it's like night and day. A worker who's alert, they're communicating clearly, they have high situational awareness, and they do their job accurately. But you take that exact same skilled person and just add a layer of fatigue, suddenly instructions get fuzzy, focus drops, and the potential for a really critical error just skyrockets. It's the same person, just in a different state, under totally different conditions.
And this is where a small lapse becomes a gigantic problem. We're talking about the ripple effect. A seemingly tiny mistake rarely, if ever, stays small on a construction site. It's such a complex, interconnected system, one small error can just cascade, gathering momentum until it becomes a catastrophic failure.
Here's the hard truth. In a system this interconnected, there's really no such thing as a small mistake. An incorrect measurement way down in the foundation might seem minor at the time, but that tiny deviation gets magnified with every single floor you build. By the time you get to the 20th story, it's a massive structural problem. Every single step depends on the one before it being absolutely perfect. Let me walk you through how it can happen. It starts with a misread blueprint. Maybe a tired engineer confuses a 6 for an 8. That then leads to the wrong material being poured into a support column. Now, that flaw is hidden, right? It's buried inside the concrete, completely invisible. And then years later, under stress, that column fails. A huge disaster, all born from a single momentary lapse in concentration. So if we accept that people are, human, and they will make mistakes, what's the solution? Well, this is where the industry is really forging a safer system. The whole modern approach to safety isn't about pointing fingers and blaming individuals. It's about building smarter, more resilient systems that actually account for our human nature.
The core philosophy is this. If you can't eliminate human error, and you can't, then you must build systems that can catch it. Instead of just hoping everyone is perfect all the time, you design processes, checklists, and technologies that act as a safety net, basically assuming that at some point someone is going to make a mistake.
So what do these systems actually look like on the ground? Well, they're usually built on 3 big pillars. First, comprehensive training that teaches not just the how, but the why behind safety rules. Second,
consistent supervision, which isn't about policing workers, but about providing a second set of expert eyes to catch things they might miss. And maybe most importantly, building a real culture of safety, where anyone on site feels empowered to stop work if they see a problem without any fear of blame.
For decades, accident reports pretty much all ended with this sentence. But worker negligence is a total dead end. It assigns blame, sure, but it doesn't solve a thing. It shuts down the investigation right when it should be starting, with the real question, which is why did the error happen in the first place?
This, right here, is the modern, proactive mindset. It looks past the individual and asks, what in our system allowed this error to happen? How can we change the process, or the training, or the environment to make sure this doesn't happen again? It's a fundamental shift from just reacting to actively preventing.
And let's be crystal clear about something. These systems aren't designed to replace people, they're designed to make people better. They're meant to augment human skill and provide safeguards against our own inherent fallibility. The whole goal is to empower the person on the ground with better tools and stronger support.
So in the end, the real challenge isn't trying to eliminate human error. Let's face it, that's probably impossible. The real engineering challenge is to build systems that are robust and forgiving enough to absorb it when it happens. Because the truth is, the only way to protect our towering structures is to first understand, support, and protect the very people who build them. Thanks for joining me for this explainer.